Lexical access. Lexical access is a very big part of language processing, and so in order to understand the neural basis of language, this is one of the kind of core computations that we need to be able to understand. So what do we mean by this term? What is lexical access? Well, let's start by considering this sentence. A 9-year-old boy 3D printed a cute cat. Happens to be an event that just happened in my house. So you understand this sentence, not because you recognize it from your prior experience, but you understand it because your brain has some generative procedure for putting these particular words together into a complex meaning. But the words themselves, you do need to memorize. So even though you don't have a prior memory representation probably of this particular sentence, you need to have memory representations of the individual building blocks, something like the words that you can kind of access in your memory. So your brain has a big dictionary of words, which are these sort of stored representations. And so the process by which your brain finds these word representations is what we call lexical access. And each memorized representation is a lexical item. So that's just a technical term for the representation that is memorized. And we refer to the dictionary in your brain as the mental lexicon. So that's just a little bit of vocabulary to get us started. So why do we memorize these lexical items? So here's a representation that's already familiar to us, the connection between the sound sequence cat and the concept of a cat. Well, we memorize lexical items because the relationship between the form, so in this case, the sound representation cat, and the meaning is in many, many cases, in almost all the cases, arbitrary. And what I mean by that is that there's nothing that tells you about the cat-like meaning or cattiness in the phonological sequence cat. There's nothing catty about that sound sequence. You can't figure out that it refers to a cat without just like memorizing that fact. So to know that cat refers to this furry creature that meows, you just need to memorize that fact. So that connection between sound and meaning. But to know what cute cat means, you just need to memorize the meaning of cute and the meaning of cat, and then the rules of English grammar will take care of the rest. So, as a child entering the language acquisition task, you get a bunch of input. You've heard about a black cat, white cat, sad cat, maybe even a dead cat. At some point, you figure out, okay, I got it. The first word specifies some property of the thing that the next word then refers to. Like that's kind of how those two words together seems to be a general procedure. And once you have that piece of knowledge, you can then talk about anything. So you can have a crazy dream about furry turtles and tell your friend about that. And as long as your friend has computed that same generalization, you can communicate about it. But the furry and the turtle parts do need to be memorized, and those are arbitrary. There are some exceptions to the arbitrariness of the form meaning connection that you may be already familiar with. So for example, onomatopoeia words are an exception to that. So these are words that sound like their meaning: drip, bam, murmur, and so forth. So we do have some lexical items like that where you kind of make it, there oftentimes these auditory words and the sound of the word itself kind of sounds like the sound that it refers to. And this kind of thing happens even more in sign language. So many lexical items in sign languages, so that's now a visual language, they visually resemble their meanings. So in sign languages, the form meaning connection is less arbitrary than in spoken languages. It's really Important to talk about this carefully though, because the relation between form and meaning in sign languages is nevertheless just as fixed or conventional as it is in spoken languages. So for example, you know, in gesturing, there's lots of ways to gesture the action of giving. And for example, in American Sign Language, the sign for given does kind of look like the way you might gesture giving. However, there's no flexibility about how you can sign this sign. You have to do it exactly in a specific way, just like you have to, you know, pronounce dog, dog, and not log or something like that. Okay, so it's a conventional fixed relationship, although more a little bit less arbitrary than in spoken languages. So lexical access works differently in comprehension and in production. So when we understand words, a very different sequence of processes happens to find those word representations than when we're talking or producing language. So that let's walk through those two kind of roots a little bit. So in comprehension, so let's think about, you know, spoken language auditor modality. You get a sound sequence into your ear. So let's assume it's some pronunciation of the word bed. Okay, so some token of bed hits your ear. So now your kind of simplest theory might say like, okay, now I'm just gonna like find the word bed in my head. But quite a bit more happens than that. So actually, in your mental lexicon, not just the word bed gets activated, but lots of other words also get activated. And in particular, you activate lots of words that sound like that. So those sounds give activation to a lot of different words that sort of resemble the phonology of what you might call the target item. So in addition to bed, you would activate beg, best, bet, fed, led, read, said, wed, and so forth. All of these all of these words sound a little bit similar. So then as a little bit of time passes by, your brain figures out that it is that bed representation that really best matches what you heard. And so that representation will get more and more excited. And the other representation, so that is the phonological neighbors of the target representation, will get less excited and they'll just kind of die down gradually. But then at the same time, there's another type of parallel activation that is happening, and that is spreading activation on the basis of the meaning of the word. So this is a whole other network that gets activated, and we refer to these as the sort of semantic relatives of the word. So from bed, you would get spreading activation to cradle, baby, hospital, maybe then doctor, and so forth. So this is showing you kind of a continuous semantic network that obviously, like the further you get away from the what I'm calling the target item here, the less activation you would get. But all these semantic representations are also connected. So that makes lexical access really interesting because there's just so much spreading activation going on, and it sort of raises this question like, well, how do you ever recognize a word? Seems like a very difficult task. Well, luckily there's always a lot of, if you're speaking in context and the word is not isolated, there are a lot of so-called top-down factors that help you find the right representation, and we'll be talking about those. So each perceived form activates a large network of lexical representations. What about in production then? So now the starting point is, of course, the meaning, not the sound. So you want to express something. Let's just say you want to express this idea. So sort of you want to externalize this kind of concept. Well, there's a lot of different ways that you could describe this particular object. You could, of course, call it a bed, but you could call it a thing. You could call it furniture. You could call it mattress, we see a mattress there, sack, so forth. Lots of different ways to talk about this thing. So when we're talking or producing language, the task is not to figure out the right phonological form, obviously, although it's eventually part of it as well, but we need to select the specific lexical representation that we want to actually use to externalize that meaning. And once we've made that specific decision, then there are a lot of other processes that will follow, like programming the exact phonological sequence and so forth, and then ultimately actually saying it if you're speaking aloud. So those are the kind of shapes of the lexical access task in comprehension and in production. So how do we then study lexical access? Behaviorally, but then also in the brain. Here are some classic tasks that have been used to study lexical access. So sort of the most common tasks that have been used in the literature for many, many decades. So on the comprehension side, so when we're understanding language, the task of lexical decision has been by far the most popular one. So this is a task where you are presented with a stimulus, so it could be visual, could be auditory, could be sign, and your task is to indicate whether that stimulus is a real word in your language or not. So for example, if we had a reading version of this task, it would have stimuli like the following, for example, so dog, yive, can, to love, blah, 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 blah. And so here you would say yes to the first stimulus, no to the second and the third one, and yes again to the fourth one. So just yes, no decisions. And then you study like what kinds of stimulus properties affect your reaction time in that task. What about in production? In production, we want to have a task that gets the person talking, okay? And usually we want to have a task that gets the person talking in a specific way because we're designing some kind of an experiment. That's a lot harder to do than just presenting your participant with stimuli that you're just gonna process. So one way in which we can get our experimental participants to say specific things that we can then study the properties of is to have them name pictures. So they look at pictures and then they have to basically name the object in the picture. It can be a more complicated thing as well, like a scene or something like that, but this is the most basic version of this type of task. So let's just say you get a sequence of pictures like this, and then you would just go across, hand, key, bag, and so forth. Okay, so these two tasks already cover a lot of the literature. And so then within these tasks, the kinds of manipulations that we would design basically fall into two classes. So on the one hand, we can manipulate or vary the properties of the stimuli themselves. So let's just say in this lexical decision task, we can present the subject with different types of words and then study the differences between those types. So for example, some of the words could be really common or frequent in the language, and others would be much rarer. That's something that affects processing really robustly. Some words might be abstract, so describe abstract concepts, like say love in this example, and others more concrete, like dog is a more concrete object that you can touch. Or we could manipulate the number of similar words that the word has in the language. So for example, along the sound dimension, some words have very common sound sequences. So for example, the word mat has very common sounds and sounds, it sounds like a lot of other words in English, and you can probably easily generate them in your head, like cat, pat, and so forth. Whereas something like yucca, a yucca plant, is much rarer. So you'll have a much harder time generating lots of words that sound like yucca. Okay, so that's a very rarer compilation of sounds. So these are like, these would be manipulations where you're varying the properties of the words that you're showing to your subjects. The other major approach is to vary the context of the word. And so here I'm referring to a very large class of priming studies. So here we're studying your response time to a specific type of word, but what we're varying is what comes before it. And we're studying the effect of the items that come before it on the processing of the current item. And because the words in your mental lexicon, or the lexical items in the mental lexicon, are so connected to each other, there are many different types of priming effects that we can observe. So most straightforwardly, if the current item was preceded by something that has a similar meaning, then your reaction time will be faster, because probably that previous word already gave that kind of boost in activation to the word you're currently seeing. So if you have, bed, mattress will get a boost of activation from the bed already, and then you'll be faster to respond to mattress. Okay, so these are the kinds of manipulations that we will then want to also carry over to our neuroimaging studies. But first, we're going to discuss whether in aphasia, it's possible to lose your ability to do lexical access, both in comprehension and in production. So that's next.